Good afternoon. Today we are going to see the problems from Space Force, and that is of question paper 2022 and 23. Now, if you are not subscribed, you can subscribe this channel, Civil Engineers Technical Hub. And in this, you can go to Engineering Mechanics playlist, where you will get more number of questions that is on engineering mechanics with a different subject. So now we have questions. So we have these videos. So now we have questions. So this question paper, this is from 2022, and this question we have that is from 2023. So now we will solve questions from these papers. So now if you will see, we have question B same in 2022 and in 2023. So you can see these questions. So these are same in the exam of 2022-23. So now we will go to this question. We have three rods meeting at point A as shown in figure. Find the magnitude of the tension developed in each rod, AB, AC and AD. And here it was mentioned, determine the tension developed in each cable. One says cable, one says rod. So now we have we have to write the coordinates. So now we have called as it is on Z axis. So we have coordinates that is 0, 0 and 5. Now we will go to BCD. Now you can see BCD is in a plane which is XY plane and passing through origin. So all Z coordinates of points B, C, D, 0. So Z coordinate for all points which are in this plane are 0. So now I will go for B. Now parallel to x-axis, we have this x-axis. So parallel to x-axis, we have this distance as 4. Parallel to y-axis, we have this as y-axis. So parallel to this, we have this as 4. You have to take parallel to that axis. That's all. Now we will go to C. So you can see for C, parallel to x-axis, we have this x-axis, parallel to it, we have 2 meters, but it is in negative direction. So we have it as -2. Then Y, we have this as y-axis, parallel to y-axis, we have this distance which is 3 meters. And Z we have 0. So -2, 3, 0. Then D, so we have to first go parallel to x-axis. We have this as x-axis. So this whole. So I can draw this. This is parallel to x-axis. So parallel to x-axis, we have this distance from y-axis. So when we are finding x-coordinate, it should be from y-axis. And y-coordinate, it should be from x-axis. So this is 4 meters. So we have on negative side. So -4. Now y, parallel to y, measured from x-axis. So we have this as y, parallel to y. So this is x-axis. So we have this distance. So this is 5. And z we have 0. So we have these coordinates. Sorry, we have y that is also minus, because it is on negative side. So we have this as -4, -5 and 0. So we have these coordinates 0, 0, 5, 4, 4, 0, -2, 3, 0, -4, -5, 0. Then we have to go in the same fashion. So whatever we have done, that is in last video. So we have first T bar. So we have concurrent at A. Concurrent at A. And then we have to use 3 equilibrium equations. Summation Fx equal to 0, summation Fy equal to 0, summation Fz equal to 0. So now we will go first T bar AB. So we have TAB, and then I already mentioned, so we have B bar minus A bar upon mod of AB. And now B bar minus A bar, if I will write coordinates, we have A 0, 0, 5, then we have B 4, 4, 0, we have C minus 2, 3, 0, and we have D minus 4, minus 5, 0. Now B bar minus A bar, so 4 minus 0, so we have to go this. So we have TAB, then we have 4 minus 0 I, then we have plus, again 4 minus 0 J, and then we have 0 minus 5K plus 0 minus 5K and divided by root of 4 square 16, 4 square 16, 5 square 25. So 32 plus 25. So we have 57. Then we have T bar AC. We are A is common because we have concurrent at A and we have tension. So all arrows are going away. Sorry, these we have TBA, we have to write actually. TBA, then we have no, yes, this is correct, AB. So we have B bar minus A bar. Here we have TAC, starting from A going towards C. So we have TAC, then we have C bar minus A bar divided by mod of AC. And then we have TAC, now C bar minus A bar. So C bar minus 2 minus 0. So I will now directly write minus 2I, then plus 3 minus 0 plus 3J, and then 0 minus 5, so minus 5K divided by 2 2s are 4, 3 3s are 9, 13 plus 25, so 38. And then we have last, that is T bar AD. So this is TAD. AD means starting from A going to D. So TAD, and therefore we are going towards D. So D bar minus A bar upon AD. And then we have this will be TAD in bracket. Now D bar minus A bar minus 4I minus 5J minus 5K. So minus 4I minus 5J minus 5K. So 25, 25, 50 and 16. So 66. Now we will write equation. So we have first equation fx0. So we will consider all x term. So we have TAB and 4I upon root 57. So we have 4 upon root 57 TAB. Then we have minus 2I upon root 38 TC. So minus 2 upon root 38 TAC. And then we have minus 4 upon root 66. And that is TAD, and this is 0. We have equation 1. Then we have second summation Fy0. So we have to write first AB, we have 4. So we have again 4 upon root 57 TAB. So 4 upon root 57 TAB. You have to see J component of all. then plus 3 upon 3 root 38 TAC, and then minus 5 upon root 56 TAD, which is equal to 0. So we have, just I will check, 4 upon root 57 minus S. And third we have summation Fz0. Then we have Z component for first minus 5 upon root 57 TAB. Then minus 5 upon root 38 TAC, and minus 5 upon root 66 TAD. Then we have plus 800 equal to 0. So we have to take 800 on opposite side. So minus 5 upon root 57 TAB minus 5 upon root 38 TAC, and minus 5 upon root 66 TAD, which is equal to minus 800. This is equation 3. And solving equation 1, 2, and 3, we will get TAB equal to 577.73 newtons. Then we have TAC 85.77 newtons. And then we have TAD 565.15 newtons. So likewise, we will get these values of the tension in the rod or tension in the cables when 800 force is acted. So likewise, we have to solve these problems of equilibrium. Now we have this problem, the rectangular 3 meter by 10 meter steel plate subjected to 4 forces as shown. So it is very clear we have this as 3 meters. So now we will go to solve this problem. Already we are with this. So we know first we have to find resultant R because forces are in Y direction only. So summation Fy, which is equal to minus 500 minus 400 plus 100 or minus 600 at C, and then at D plus 100, and we will get minus 9 minus 15 plus 100 minus 1400 Newton. So my value of resultant is 1400 Newton, but it is acting in downward direction. So now we can write, first we have 500 Newton force, 500 Newton coordinate we have 0, 0, 0. Again it is in XY plane, so Z coordinate of all points are 0. Then we have at B 400 Newton, and as it is on Y axis, so we have X0, Y we have 10 meter total parallel to Y, parallel to Y. It is on Y, so X should be 0. So we have this as 10, we have 0. Then we have 600 Newton, which is at C, and now it is on X-axis. And this distance, when it was mentioned 10 by 3, so we need not require to us not seeing. So this should be 3 meters. So we have 3, 0, 0. And 100, so I can say 100. So this I can say in opposite direction of all other. So I will mention it as minus and the coordinate. Now parallel to X, we have this distance. So we have 2 meter. Parallel to Y, so we have this distance 5 meters, and Z we have 0. Now we know we have X equal to summation Fx upon R. Now F we have 500 into 0. You have to multiply it by X coordinate plus 400 into 0 plus 600 into 3 minus 100 into 2, because it is in opposite direction, my resultant is downward. And our Verignon's theorem, if we will see theory part, Verignon's theorem says moment of forces about a point equal to moment of resultant about same point. So we have upon 1400. So we will get x bar equal to 1600 upon 1400. And we have this value that is equal to 1.14 meters. And then we have y bar summation Fy upon R. Now F we have 500. It is at origin, so no moment about both axes. 400 into 10 because it is on y-axis. Then 600 into 0 because it is on x-axis, so y is 0. And minus 100 into 5 upon 1400. And therefore we will get it as 3500 upon 1400. And we have this as 2.5 meters. So we have R. Now X we have 1.14, means somewhere here I will say. And Y we have 2.5 meter. So we can show resultant over here. So resultant with value of 1400 Newton. And you can write R 1400 Newton acts at X is 1.14, Y is 2.5, and Z we know it is in XY plane, so Z0. Now similar, we have one problem, that is this last problem. This was asked in 2022, and now whichever we are going to solve this. So this was in 2022. Now we are solving that problem. This was asked in 2023. So as equilibrium is same, so I have considered this in this. Now you can see value of F1 is given 8 and F2 is 9. So we have F1 is 8 and F2 we have 9. Now again R we have summation Fy, not 0, we have resultant, keep in mind. So F1 8, we have F2 9, then we have 12, then we have 6. All these are in downward direction, so we have sign minus, so equal to minus 35 kilonewton. So we can say R equal to 35 kilonewton, which will act in downward direction. Now we will write the coordinate. We have coordinate of F1. So it is on x-axis. So y is 0. Parallel to x, we have distance, this distance. So 6 plus 16. So we have this as 22. Y0, we have Z0. Now F2 we will find. F2 is on y-axis. So we have x0. And parallel to y-axis, we have this distance, which is 8 plus 12. So we have this as 20. And then Z we have 0. Because all points are in xy plane passing through origin. Then we have 12 kilonewton. So you can see 12 kilonewton, we have parallel to x. We have this distance, which is 6. So we have x6. Y parallel to y. So we have this distance, only this part. So this distance is 8. So 6, 8, and then we have 0. Now for this 6 kilonewton, so for 6 kilonewton, we have x. So parallel to x, we have from this to this, 16 for 20 plus 6, 26. Parallel to y, we have to go this distance, 12 plus 8, 20, and z we have 0. So just I will check my coordinates, 22, 0, 0, 0, 20, 0, 6, 8, 0, and 26, 20, 0. So now we know we have x bar or x, you can write summation fx upon r. Now we have 8 kilonewton, 8 into 22. So we have 8 into 22. F2 we have 9 into 0 because it is on y-axis. So we have 12 into 6. Coordinate of x is 6 plus 6 kilonewton, which is over here. So 6 into 26. So we have 6 into 26 and divided by 35. And then we have this value that is equal to 11.54. 11.54 meters. And for y bar, we have summation Fy upon R. Then we have 8. F1 is 8, 8 into 0 because it is on x-axis, plus 9 into 20, it is on y-axis, plus 12 into 8, plus 6 into 20, and divided by 35. And then we will get y bar as 11.31 meter. So we have R, we have 35 kilonewton acting downward at, we have X 11.54, Y 11.31 and Z 0. So likewise, we have to solve these problems. I will just check 9, 0, 12, 6 and 626 upon 35, 8, 0, 9, 20, 12, 8, 620. So likewise, we have to solve the problems and then we will get the answer. So now we will stop here only. So these are the problems which are related with space forces. And now we will stop here only. If not subscribe, subscribe to this channel, that is Civil Engineering Technical Hub, and go to mechanics playlist, from which you will get number of questions on these mechanics, space forces. Thank you.